In this tutorial, we will look at the terms stress and strain and try to get an understanding of why we want to use these terms instead of force and deformation. So when we apply force to an object, we know that it will deform. So here we have an object and we apply a force. The original length of this object is L, and there is a certain amount of deformation, delta L, as a result of applying that force. So if we consider two different size objects made of same material, in one case a taller object and another one a shorter object, and we apply the same amount of force on the top surface, we will observe that the tall object will deform more than the short object. The deformation is influenced by size, shape, and the material that the object is made of. Now, if we are interested in the material properties of that object, then we need to eliminate the influence of shape and size of that object. We convert the force into stress by dividing force by area. So we will use the term sigma for stress, and sigma equals F over A, where F is the force, A is the cross-sectional area on which the force is applied. The units of force are Newton, and the units of area square meters. So we have newtons divided by square meters, and you know that is also called Pascal. Next, we convert deformation delta L into strain by dividing delta L by the total original length of the object. So we use the term epsilon, the Greek letter epsilon, for strain. Epsilon equals delta L over L. The units, of course, are meters divided by meters, or strain is dimensionless. And it is the change in length divided by the original length. So instead of using force and deformation, where the size and shape of that object will influence how much deformation is occurring based on the applied force, we use the terms stress and strain. So we eliminate the influence of shape and size and use stress and strain anytime we are interested in the material properties of that object.